Hello everyone, welcome to yet another lecture of industrial engineering. In the last lecture we studied regarding method study, and today we'll be covering a topic called work measurement, which is also a part of methods engineering. So work measurement, as the name suggests, is also called as time study. We have discussed that in the last lecture. So it is also called time study. So as the name suggests, work measurement involves the study of time. So it is the measurement of the time for doing a particular job. So there are plenty of methods involved in work measurement, and it is also concerned with the investigating, reducing, and subsequently eliminating ineffective time, so that there will be maximum efficiency. And the methods which you use for work measurements are the first method is called the time study, the second one is called work sampling, the third one is analytical estimating, and the next method is called predetermined motion and time study, or PMTS in short. So in this lecture we will be studying the different methods which you use for work measurement, and then we will do some problems so that the idea is very clear. So we go to the first method, that is called the time study method. So as the name suggests, it is the study of the time necessary to study of the time necessary to carry out a given activity. So accurate measurement of a time is necessary from limited number of observations. Activity should be should be at a defined level of performance. So you study regarding the time required for a particular activity which is at a defined level of performance. So before we go into the details, let's study some terms which you use during a time study. So for doing problems that might be that is essential. So the first term is called the observed time. So observed time is the time recorded by stopwatch by work study man during the observation of the of activity of the operator. So that is called the observed time. So it is the time recorded by stopwatch. So the time is recorded during the work study by the work study man using a stopwatch, and he is really understanding how much time is needed for completing a certain job. So that is known as observed time. Now rating factor. Rating factor is actually observed performance divided by normal performance. So there will be an observed performance value and a normal performance value. So if you divide this, then you get what is called the rating factor. Suppose if the rating factor is say 1.2, then that means that the worker is or the operator is working at a faster rate. That is the normal working rate is compared to 100 percentage, but your worker is working at a rate of more than that, that is 120 percentage. So that is the idea behind a rating factor. Now you come to what is called normal time or basic time. Normal time is actually the observed time into the rating factor. Suppose if you are having a rating factor, you multiply that rating factor into the observed time, then you get the normal time or basic time. For doing the problems, these terms are very essential. Now we go to allowances. So some time allowances are given during operations in a plant. The first allowance is called relaxation allowance. Relaxation allowance are given to certain employees, like the for the lunch break, for example, is a kind of a relaxation allowance. Also the tea break is an example. All the breaks which helps the worker to recover from fatigue. which helps the worker to recover from fatigue can be termed as relaxation allowance. Now, contingency allowance is a kind of allowance that is located during planning for unscheduled events. Suppose if there is a sudden breakdown, that is an unscheduled event, and this contingency allowance is pre-planned, so that in case of unscheduled events like this, you can give an allowance, or uh, you can allocate this kind of allowance during planning. Now, what is meant by standard time? The standard time is the basic, that is the sum of the normal time plus the relaxation allowance and the contingency allowance and any other allowances. So the sum of all these allowances with the normal time will give you the standard time. So if you have a value of standard time, then you can say that this is the standard time for finishing my job. So these are the terms which you use during time study. Once again, the observed time, that is the time observed by the work study man during the observation using a stopwatch. The rating factor, that is observed performance divided by the normal performance. Then the normal time or basic time, that is normal time is equal to observed time into the rating factor. So suppose if you are having a rating factor of 1.2 and the observed time is say 2 minutes, then the normal time for finishing is 2 minutes into 1.2, that is 2.4 minutes. And then you come to the allowances. Allowances are the extra time which is given so that the work is completed without fail. So allowances are of two types: relaxation allowance and contingency allowance. Now, standard time is the sum of all these times which we already saw, that is the normal time, the relaxation allowance time, the contingency and any other allowance which are available. Now we'll do a problem so that the idea is very clear. So in this problem, what is given is assuming that total observed time for an operation of assembling an electric switch is 1 minute. So the observed time is 1 minute. If the rating is 120 percentage, so the performance rating is 120 percentage, find the normal time. So if an allowance of 10 percentage is allowed for the operation, determine the standard time. So there is an allowance of 10 percentage. So what all is given? So first of all, what is given is you have what is called the observed time. So what is the observed time? It is 1 minutes. And the performance rating is equal to 120 percentage. So from this equation you can find out the normal time. So what is the equation for normal time? Normal time is equal to observed time into performance rating. So that is 1.2 minutes. So that is the time he will take for completing the job. That is a normal time he will take. But there is an allowance of 10 percentage. So there is an allowance of 10 percentage. So the standard time should consider that allowance too. So the standard time is equal to your normal time, that is 1.2 plus an allowance of 10 percentage. So into 10 divided by 100. So this will give you the answer. So that is 1.2 into plus 0.12, so that is 1.32 minutes. So this is the standard time. So this is what an industrial engineer will do for calculating the time for performing a particular job. To understand it better, I will go to one more problem. So to understand the concept, we are going into the second problem. So here an operator manufactures 50 jobs. So for manufacturing 50 jobs, he takes 6 hours and 30 minutes. If this time includes the time for setting his machine, calculate the operator's efficiency. Standard time allowed for the job is as follows. So the standard time for setting the machine is 35 minutes. Production time per piece is 8 minutes. So what is given? So the actual time taken by the operator is given. So the actual time is how much? 6 hours and 30 minutes. So that is equal to, you will have to convert it into minutes, that is 6 into 60 plus 30. So that is 390 minutes. So you got the actual time and the standard time is also given. The standard time is the sum of what is given here. So the standard time allowed for the job is as follows. So that is the setting time plus production time. So setting time is 35 minutes and the production time per piece is given. So you have a total of 50 pieces. So 8 into 50 will give you the time for 50 pieces. So that is 35 plus 400, so that will be something around 435 minutes. Now you are asked to calculate the efficiency of the worker. So to find out the efficiency, it is very clear from the from what you have calculated here, that is the actual time divided by the standard time. Actual time divided by the standard time. So what is the actual time here? That is 390 and the standard time is 435. So you'll get a value as 1.15. So that into 100 will give you the answer in percentage. So that is 111, whatever, that much amount of percentage. So that is the efficiency of the operator. So hope the idea is clear. Now we'll go to what is meant by work sampling. Work sampling or activity sampling is a method of finding the percentage of occurrence of a certain activity by statistical sampling and random observation. So the basic idea is you take a sample and do the statistics on the sample, and you make random observation from the sample. So after doing the problem, you will be very clear with the idea. The fundamental concept of work sampling is that the sample taken at random from the large group tends to have the same pattern of distribution. That is, when a small sample is taken, studies shows that it is similar to the large group as a whole. So the work sampling has will give you an accurate result. That is what the studies show. Now to do the work sampling, this is the equation which you use, that is P into S is equal to K root P into 1 minus P divided by N. Here S is the accuracy required in fraction, P is the percentage occurrence of the activity expressed in decimal, N is the number of observation required for the desired confidence level and margin of error, and K is 1 when the percentage is 68.27, that is 68.27 confidence level, then you go for the value as 1, 1.96 if the value is 95, and 3 if the confidence level is 99. So this is the equation, and it will be clear when you do an example, when you see an example. So in this particular problem, as a shop supervisor want to know the percentage of time. So you are asked to calculate the percentage of time a shop in his department is idle. So the percentage of time a shop in his department is idle. So that is actually P. So estimate the number of observations necessary to give a 95% confidence level. So the confidence level is 95%, so that the result are accurate within 5%. So a pilot study showed that 60 times out of 200 observations the shop was idle. So for the first thing, that is the first part was to calculate the idle percentage. So that is very clear from this particular data. So that is the percentage of a time the shop in his department is idle is P. So that is P is equal to 60 divided by 200. So that is the percentage of idle time. So that is something around 3 by 10, that is 0.3. Now what is the equation which you will have to use? So you should be using this particular equation. See, what is P? P is the percentage of occurrence of the activity that expressed in decimal. So in this particular case, the activity was idle time, and S is the accuracy required in fraction. So is the accuracy given here? Yes, the accuracy given here is 5%. So S is equal to 5%, that is 0.05. Now what else do we know? Now the value of K when the confidence level is 95%, the value of K is 1.96. So K can be written as 1.96, or you can approximate it to 2. And okay, so everything is given. Now you are asked to estimate the number of observations required. That is, you are supposed to find out the value of N. So P, what is the equation? P into S is equal to K root P into 1 minus P divided by N. So P into S is equal to K into root P into 1 minus P divided by N. Okay. So what is the value of P? P is 0.3. What is the value of S? That is 0.05. And the value of K, you have assumed it to be 2. You have assumed the value of K to be 2, and the value of P is 0.3. So 0.3 into 1 minus 0.3, the whole divided by N. So you can find out the value of N from this equation. So this is how you do this kind of problem. That is, if you are asked to find out the percentage of time, or if you are asked to find out the number of observations, then you go for the work sampling method, and this is how you find out, and the equation used is clear. And the answer is something around 37. So the value of N is something around 37. So the next method is called the analytical estimation method. In this particular method, what you need is experience. So practical experience and some synthetic data which is already there is used for estimating the time in this particular method. So the steps which you do is as follows. That is, the first step, uh, the whole job is broken down into smaller and individual tasks, and after that the time values for these small elements, okay, this the individual tasks are broken down and certain time values are given to these tasks. So to the remaining elements for which synthetic data is available, the estimator gives the suitable time values from his part knowledge and experience. Again, see, the evaluator has experience and knowledge about the process. So for the remaining elements for which the time values are not available, or the synthetic data are available, what he does is from his part knowledge and experience he give the time values to the remaining elements. So if you add the process 2 and 3, then you can get process 4. So that is the 4 steps which are involved, and after that what is left is the allowances. So the allowances are also supposed to be given. So that is the 5th step. So usually what you do is you don't give individual allowances, you give a total allowance of say 10 to 20% of the total basic time. So you got a basic time in the 4th step, so into that you add 10 to 20% of the basic time again, and then you get the total relaxation which is required, or the relaxation allowance which is required. And if you have any additional allowances, then you add it again according to the situation. So this is called analytical estimation, and the important thing which you will have to remember here is the estimator should have a practical experience, and also there should be some synthetic data which should be available, and the estimator should have a great knowledge. Of course, if he is having a experience, then he is going to have some kind of knowledge. So this is called analytical estimation. And then we come to the next method, that is called the predetermined motion time system. Predetermined motion time system is similar to the motion analysis which we already saw. The only difference is that here also you use the video cameras to analyze the motions, and there you analyzed the motions, but here what you analyze is the time required for doing a particular motion. Okay, so the steps, again will come into the steps. So you select the number of workers, or a large number of workers doing varieties of jobs under normal working conditions in the industries. So you select the number of workers doing the varieties of jobs, and after that you start recording the job operations on a movie film. Okay, again what is done here, micro motion study is done here, and you analyze the film and note down the time. See, this is the difference. You are noting down the time taken here to complete each element, and then you complete the data and compile it in the form of a table or a chart, and then you will be able to analyze the time required for doing particular motion. So this is all regarding time study. Hope the idea is clear. Please let me know if you have any doubt. Thank you.